Hello everyone and welcome back. I am Mr. Cobalt, and in this video we are going to do a mass-to-mass conversion using our balanced equation. So in the previous video we did a mole to mole, but now we're going to go from mass to mass. And so I want to point out my roadmap here. And so again, using this roadmap, this tells us if we're going to start at one point, how to get to another point. So in the last problem, we just need to do a mole to mole conversion. So we started here and we ended up here, and we had to use the mole ratio from our balanced equation to do that. But in this problem, they're going to ask us to go from the mass of one substance to the mass in a different substance on our equation. And so we're going to have to start at this end and convert from mass to moles, and then from moles of A to moles of B, and then to moles of B to mass of B in grams. And so this is going to be a very useful roadmap to know. So if we look at our problem, we're given the photosynthesis equation, which is 6 carbon dioxide molecules of gas plus 6 molecules of water in the presence of sunlight will yield 6 molecules of oxygen and 6 molecules of glucose, C6H12O6. And so here's our balanced equation. And so in this particular problem, they're saying, suppose a particular plant consumes 37.8 grams of carbon dioxide. So we're looking at carbon dioxide here, and it consumes it in 1 week. Assuming that there is more than enough water present to react with all of the carbon dioxide. So that means that the carbon dioxide is not going to limit the reaction. So we have plenty of water to react with all of our carbon dioxide. So we have 37.8 grams of carbon dioxide. So one of the worries might be, well, do we have enough water to react with all that? If we don't, then not all of the 37.8 grams is going to react. So the problem is telling you you have more than enough water to react with all of this. So that's not going to be a problem. So the water is not going to limit how much you can produce. So assuming that we have enough water to react with all of our 37.8 grams of carbon dioxide, what mass of glucose in grams can the plant synthesize from that amount of CO2? So the question is asking us to go from a certain amount of CO2 to a certain amount of water. Or glucose, glucose. So the two things that we need to convert between is carbon dioxide and glucose. So this is going to be our A and this is going to be our B. So they're giving us grams of carbon dioxide. So we got to start here in our roadmap. And so the roadmap is telling us what we must do. So if we're going to have to start with grams of A, glucose, of carbon dioxide, and we need to get to mass of glucose. So in order to do that, we need to first convert the grams of carbon dioxide to moles using the molar mass of carbon dioxide. And then we're going to need to convert moles of carbon dioxide to moles of the glucose. And here we're going to use the mole ratio from the balanced equation. So the mole ratio is 6 carbon dioxide to 1 glucose. So that's the mole ratio we're going to use. And then once we convert to moles of glucose, we then have to use the molar mass of glucose to convert to mass of glucose. So that's the process. So let's start with 37.8 grams. So we're going to start with 37.8 grams of carbon dioxide. And now we're going to do our first conversion. And our first conversion is to convert grams to moles using the molar mass. Carbon dioxide has a molar mass of 44.01. Okay, so there's our grams of CO2. and that's going to be moles, 1 mole of CO2 on top. So the grams of CO2 are going to cancel out, leaving moles. And so there you have your mole. Oops, we don't need an equal sign there. But so now we have moles. So that's the first step. So now we've gone from mass to moles using the molar mass. And now we need the second step, which is the mole ratio to go from moles of A to moles of B. So we need to go from carbon dioxide and glucose. So the mole ratio is 6 to 1. So I need another conversion factor. So since I have moles of carbon dioxide on top, I'm going to put moles of carbon dioxide on the bottom. And that's going to be 6 moles. 6 moles of carbon dioxide because the coefficient is 6. And then 1 mole of glucose, C6H12O6. So that's 1 mole of glucose. So the moles of carbon dioxide cancel out. Now I have moles of B. So I have moles of B because I used the mole ratio to convert. So now I have moles of glucose. And so the question is asking what mass of glucose in grams. So I need grams of glucose. So my last step is use the molar mass of glucose to go from moles to mass. And so that would be the last step. So how many grams is this? This is going to be about 180 grams. Let me just double check to make sure. 180.2 grams of glucose, C6H12O6. And then we have 1 mole. I need to switch this around. So notice that I put grams on the bottom and they're supposed to be moles. So that's not going to cancel out. So I need to switch that. So that's how you can always keep track and make sure you're not making a mistake. So I need moles on the bottom. So 1 mole of glucose, C6H12O6. And then you have the 180.2 grams of C6H12O6. And so now the moles of glucose cancel out, and now you have grams of glucose on the bottom. And so that tells me I'm done because that's what the problem wants. What mass of glucose in grams? So now that I have grams of glucose on the top, I am done with my conversions. No more conversions. All I need to do is do the calculation. So I'm going to grab my calculator and let's calculate this really quick. So I have 37.8 times 180.2. Now I divide by the bottom, divided by 44.012, divided by 6 equals, and that gives me, so the answer is, I'll write it down here, the answer is 25.794. So 25.794 grams of glucose, C6H12O6. Okay, so, but I'm not done yet because I need to figure out the number of significant figures in my answer. So once again, I go back to what I multiplied and divided by, and I need to eliminate or ignore anything that's exact. So the 1 to 6 ratio is exact because those are exact numbers from the balanced equation. So I don't need to worry about those. The 180.2, that's a measure, that's my molar mass, so I need to pay attention to the 180.2. This is a molar mass, I need to pay attention to that. And this number is a mass of grams that they gave me, and that is also a measure. So my answer can only have the same number as the least number of sig figs that are given in the measures that I'm using in my calculation. So here I have 4. Here I have 5, and here I have 3. So 3 is the lowest number. So I can only have 3. 1, 2, 3. So I'm going to cut it off here. This is a 9, so I need to round this to an 8. So the answer would be 25.8 grams of glucose, C6H12O6. And so that would be the answer that I would report. Okay, so I hope this is clear. So this is a mass-to-mass conversion, and I used my roadmap, and I used the molar masses of the substances to convert between moles and mass, and I used the mole ratio to convert from moles to moles in my balanced equation. So using your molar mass and using the mole ratio in your balanced equation is going to be very important and very popular or common tools to use for solving these problems. I hope this was helpful, and if you enjoyed it, please share this with other people, make a comment in the comment section, subscribe to the channel, hit the notification bell for notifications when I put out more videos. Thank you for joining me, and I'll see you next time.